be looking at where we left off the last time. We are still looking at measures of central tendency. We talked already about the mean, the median, and then the mode. And today we are going to start with the shape of the distribution. How do the shape of the distribution relates to the mean, the median, and the mode? So specifically, we will be looking at symmetrical distribution and then skewed distribution. All right, so that's where we will be starting off lecture today. All right, so a symmetrical distribution has a single peak and a bell, and if a symmetrical distribution has a single peak and it is a bell shape, then we call that the normal distribution, right? So this is an example of a normal distribution. All right, this is a normal. So there are so many different symmetrical distribution, but the one that we are interested in is the normal distribution. All right, so this one is symmetrical, okay, but we are not interested in this type. We are interested in the one that is bell shaped. All right. Um, Now we're going to be using this terminology, skewness. Skewness refers to anything that differ from any distribution that differ from the normal distribution, right? If it is not symmetrically, then it differs from the normal distribution, and we say there's some skewness in there. I'll be explaining to you the concept of skewness today. All right, so let's start with the three things that I need to talk about right now. The first, we talk symmetric distribution, and we said we're focusing on the one that will end up giving us some shape like a bell shape. So if I connect these, I'll get something like a bell shape, more close, something close to a bell shape. All right. Now, in a bell-shaped distribution, so um, for bell-shaped bell-shaped distribution, they are symmetrical. If the distribution is symmetrical, then the mean is equal to the median. It's equal to the mode. All right, when you look at the bell shaped, it is bell shaped, and then the tallest part is always the mode. All right, the mode is like the tallest part of it, but it happens that it's also the same as a median because it's the same in the middle, and the same as a mean because the mean happens to be in the middle. All right, so in a symmetrical distribution, the mean, the median, the mode, they are all equal. So you see this expression here. It's saying that normally distributed data, mean is equal to median is equal to mode. All right. So those are something that I want you to know. If the distribution is normally distributed, then the mean is equal to the median, then it's equal to the mode. Okay. Now, there are, if it is not symmetrical, then the distribution will be skewed. Skewed. Now we have skewed to the left and then skewed to the right. Skewed to the left is also called negative, or skewed negatively, or negatively skewed. Skewed to the right is also called positive, or skewed to, yeah, positively skewed. Okay, now in a negatively skewed, like you see here, in a negatively skewed, all right, the long tail is on the left. So let me say long tail on the left side. The long tail is on the left, all right, this side. The long tail, you have a long tail on the left. The long tail is on the left side, then it is negatively skewed. Okay, now for positively skewed, the long tail on the right. All right, so if the distribution is positively skewed, then the long tail it's on the right. Okay, now let me mention this very important thing, the relationship between the skewness and the central tendency. All right, so let me start with skewed to the left, skewed to the left, which we said it is called negatively skewed. All right, so let me start with that. Let me draw a diagram. So the long tail is on the left side. Now, if something is skewed to the left, all right, if this is a graph, usually the low values are on the left side, and then the high values are on the right side. Now, for most graphs, almost all graphs, the peak, where you have the peak, right, the tallest place is the mode. Where you have the peak is the mode. Where you have the peak is the mode. Now, the mean would always be dragged towards the long tail. So the mean will be somewhere here. All right, the mean would always be dragged towards the long tail. So the mean will always be pulled towards the long tail. The median, it's always in between the mean and then the mode. All right, so the median is here. Median is here. This is the median. So the mode is the peak. The mean will be drawn towards the long tail, the side of the long tail. The median will be in between those two. All right, so when a distribution is skewed to the left or positively skewed, what we would say is that the mean is lower than the median. In other words, mean, if I have to write notation, mean is less than median. And in most cases, median is less than the mode. All right, so if it is skewed to the left, the mean is less than, so skewed to the left, you see here, mean less than median, median less than mode. So that is a situation where it's skewed to the left. Now, let me now look at when it is skewed to the right. When it's skewed to the right, let me see if I can pull this up a little bit. Okay, good. Now, when it's skewed to the right, so let me say skewed to the right, which we say positively or positively skewed, right? Now, let me draw a little diagram. Now, remember that when it's skewed to the right, the long tail, it's on the right side, right? I hope this doesn't look nice. So let me make it beautiful. Hopefully I could. Okay, so here the long tail is on the right. Okay, long tail. So the long tail is somewhere here. So long tail is on the right. Remember that the mode is always the peak side, right? So this is the mode. It's always on the peak side. The mean will be pulled towards the side of the long tail. So the mean will be pulled towards the side of the long tail. Now, no, and then the median will be in the middle of those two. So median. So in the skewed to the right, what you would see is that the mean is higher. All right, so mean is higher than the median. All right, we know, for example, that you have low values here, and then you have high values here, right? So the mean is on more towards the high value side than the median. Okay, so you could then say that mode less than median, median less than mode. You could say this one. Okay, so take note of how the measures of central tendency relates to the mean, median, and which is the mean, median, and the mode relates to the shape of the distribution, whether symmetrical, skewed to the left, or skewed to the right. Okay, so we've seen, so sometimes though, you could just be given the data. All right, let's say they tell you the mean of something is 4, the median is 4, the mode is 4. So we know that here the mean is equal to median is equal to the mode, right? So we can conclude that this distribution is what? Symmetric. The distribution is symmetric, maybe a bell-shaped, something like that. Now, I've already spoken about skewness to you. All right, so this is like a repetition, but take note that skewed to the left also means negatively skewed. The long tail is on the left side, and usually because of that, because when you have a situation like this, the low values are here, and then the high values are here, right? So when it's skewed to the left, you have few outliers that are on the low side, the left side. All right, because the long tail on the left, right? The long tail on the left. The long tail is on the left side. So more likely you could have certain values that are here that are far away from the rest of the group. When it's skewed to the left, most of the values are on the high side. Most values are on the high side. Now, so, and a good example of skewed to the left, it's the years of education. Years of education, right? Years of education. When you, like these days, very few people maybe have maybe only high school or less than high school. Most people have so many years of education. You're talking about a lot of people with college degrees, either bachelor's, master's, and PhDs, postgraduate degrees, and stuff. So there are more people who have um, let's say, higher values than low values. All right, I think there was an example in here where they were looking at something like, if you look at um, the NBA players, um, most people are tall, and then you have very few of the players that are maybe short. I don't want to name names. Okay, so that is skewed to the left. Now, skewed to the right, we also said, so this is like a repetition, but I guess repetition is good for students. All right, so skewed to the right is also called positively skewed. The long tail, it's on the right side. Long tail on the right side. All right, so there are possible outliers, but then the outliers might be more on the high values. So these are high values over here, and then low values over here. So you have a lot of low values, and then you have very few high values. The good example is income. Right? Income is a good example of skewed to the right. Income is a good example of skewed to the right. Income, because a lot of people, maybe including myself, we are here. All right, we are making low sacrifice, I guess, and then you have very few people who are making a whole lot, right? A whole lot of money. Okay. Another example could be house prices. Um, House prices. In most areas, most of the houses might have maybe within a particular range. Then you could have very few houses that would be very expensive in the same locality. All right, so house prices are example of a positively skewed, and an income is also an example of a positively skewed distribution. Okay, now once again, note that the mean would always draw towards the higher side. So in the positively skewed, the mean is higher. The mean is higher than the median, or larger than the median. All right, in a negatively skewed, the mean will be drawn towards the long tail, so the mean is lower than the median. So that's what I want to mention about skewness. Okay, sometimes you will be just given a data. Maybe if they don't give you data, they'll give you the measures, and then they want you out of the measures to decide whether it's skewed to the left, right, or not. So one of the things you could draw a line and put the numbers there. So 51, 51.5, 60, and then let's say 70. Now, so this is a mean, this is a median, and this is the mode. All right, so if you see something like that, the mean will always be drawn towards the long tail. So it means that the long tail is on the left. So if you just have these numbers, you should be able to know what it means. So the long tail is on the left, so you have some long tail on the left, then it goes like this, and then the peak is over there. So this is like the mode. This is a mode. The long tail is here, which is the mean, and then so this is skewed to the left, skewed to the left. Okay, now we could have maybe a similar situation where we are given certain numbers, we're given this, and that, and we want to determine how it is skewed. So let's see what we have. Um, 20 is here, let's say 30 is here, and then, oh, yeah, and 36.1 is over here. Yeah, what's the question? Did anyone have a
Actually,
question?
sorry.
Okay. All right. So now this is a mean, this is a median, and then this is the mode. So here the mean is always drawn towards where you have the long tail. So you see that the long tail is on the right side. All right, the long tail is on the right side, and then the peak is over here. So peak is here, long tail is here. So this is skewed. The long tail is on the right side, skewed to the right, skewed to the right, something like this. Okay, so when you are given this measures of central tendency, you should be able to come out with what kind of skewness you have. Okay, so that's it for skewness. I think I've made mention of these already. House prices in the U.S. A lot of the houses may have low price, and you have very few, very few. If the curve is coming down, means very few, right? So the long tail on the left. So that will be skewed to the left. All right. The weight of a sample of 30-year-old men, like weight in general, it's symmetrical. Weight, height, usually empirical studies have shown that they are symmetrical. Height of all MBA students, that will be skewed to the right because you have a lot of them here, and then you have very few who are somewhere here. Yeah, Shahida.
Drawings backwards.
Say again.
It was skewed to the left and right, but I think it's actually the opposite, the way you drew it.
Oh, boy, thank you. So actually, this is skewed to the right. Thank you. This is skewed to the right. And then this is skewed to the left. Thank you. And this is symmetric. Very much. Thank you very much. Okay. Now, the next thing we're going to be looking at, all right, it's called weighted mean. Weighted mean. Now, when you calculate a mean, for example, if I give you a numbers like what, 2, 2, 4, 6, 8. Let me just make this small set of numbers, right? And I say find a mean of this. All right, you're gonna do 2 plus 4 plus 6 plus 8, and then you divide by 1, 2, 3, 4. You divide by 4, then you get some number. You get what you get is called a mean, right? So here, for example, 10, 20, you get 5. So 5 is a mean. Now, this is based on assumption that the weight is one, each one carries the same weight. In other words, you have 1, 2, 1, 1, 4, 1, 6, 1, 8. Now, suppose we double the 8 to be 2, then this is no longer true. All right. If you have two eights, then this is no longer going to be true. So in a weighted mean, we apply the weight of the value to the value. All right, we apply the weight of the value to the value. The places where we use weighted mean a lot has to do with how your semester GPA, your cumulative GPA, your class grades are calculated. All right, weighted means are very important because as a student taking any class at college level, you should know how your grades are calculated. And most times, professors use weighted means. For example, in this class, all right, even though you're going to have a lot of homeworks, the homeworks don't carry too much weight. What really, really carries weight is your test. All right, each test is 20% of your grade. All right. So, and then we do three tests. So all tests in our class, for example, is 60% of our grade. So if you don't do well in the test, but you do very well in the homework, you're not gonna like get a very good grade. All right. So which means that when there's a test, you really, really have to take it very, very serious because it carries a whole lot of weight. It's the test, even though it's three tests, right? It's more than all the homework, the even to quizzes, everything combined. It's still more than that, right? So the test is very important. So how do you calculate your grade when the weights are not the same? That's what we're going to be looking at. All right. So let's look at like example. So in general, when we say weighted mean, when we say weighted mean or weighted average, what we do is that we take a value. So we take the value and then we multiply the value by the W, by the weight, or whatever weight is assigned to it, and then we divide by the sum of the weight, sum of the weight. All right, so this I'll say the product. Let me just call it the product. So you're gonna do the sum. So the weighted mean. So the weighted mean is gonna be the sum of the products. Let me put an X here. Mean the product of the value times the weights, all divided by the sum of the weights. Okay, and this is very important. Like I'm teaching this class called Theory of Interest this semester, and it's an upper level class, and basically we use a weighted mean to do some things. So some of the students they just saw this maybe in their freshman year, and then all of a sudden we have to use it in some big time calculation. So this is really, really very important. Okay, so why don't we just see how it can be done? Okay, so this an example. So it says that, so let me actually make a little table here. So there was a couple of tests, what the students score, what weight the teacher gave the test. All right, so X and then W, and then we need the product, X times W, which is the product. Okay, so in the class there was a mid-term. The students scored 83. Then there was a final. The students scored 95. Now the teacher said that every midterm is worth 40%, so you're gonna write 0.40, and the final is worth 60%, so you're gonna write 0.60. All right. Then we need the product of the score and the weight. We need X times W. All right, so we're gonna do 83 times 0.40. That will give you 33.2. Now, what does this 33.2 means? That it means that out of the 40% for midterm, the student gained 33.2, meaning that the student lost about what? Let's say 6.8, right? The student lost about 6.8. Now, then we come to the final. So you're going to do 95 times 0.6. That gives you 57, which means that out of the 60 points for the final, the student gained what? 57. So the student lost only 3 points from that. Okay, well, the weighted mean says we need to find the sum. We need the sum of the weights. We also need the sum of the products. All right. So the sum of the product first will give us 90.2. The sum of the weight will give us 1. And then it says weighted means. Weighted mean or weighted average is the sum of the product, which is 90.1.2 divided by the sum of the sum of the product divided by the sum of the weight. All right, the sum of the weight is 1, so that gives us 90.2. Student got A because it said 90 is A. Minimum for 90 is A, so student got A. So that is how to find weighted means. Okay, so I have this big thing here. Let me actually bring it over here. All right, so there was this long question, but it's reduced also into this table, so that will make it easy for you to see. So the test student score 86, midterm student score 96, final student score 82, computer lab student score 90 something, homework student got 100%. Right now, we were told that all the tests is 50%, midterm 15, final is 20, lab is 10, homework is 5%. Okay, so those percentages forms the weight. All right, those are the weights for the class. Those are the weights. All right, and then this is the score. So you're going to multiply the score by the weight. You write it down, score by the weight. Then, so this is the product. Okay, so what we do is we add all the products, we get this, we add all the weight, we get this, and then you get that. So that's just then scored that. So this is like a B plus. Okay, so that's how to calculate weighted means. Now, this is how your semester GPA is calculated. All right, this is how your semester GPA is calculated. You have, let's say, the student had A in math, so it's 4 points. Usually, the school call this in quality points. Quality points. All right. Then B is 3, A is 4, and then C is 2. The credit serves as your weight. The credits of each class serves as your weight. All right, so credit is your W. Credit serves as your weight. So when you're calculating your semester GPA by yourself, the credit for each class is the weight attached to the class. All right, so here the math class for this particular college was 5 credits, history is 3, health is 2, art is 2. So you multiply the score by the weight. So here we have 4 times that gives us 20. We have 3 times 3, that gives us 9. We have this times that gives us this times this, that gives us that. And what we do is we add all these numbers. All right, I think we get 41, is it not? 29, 37, 41. And then, so this is the sum of the products, right? Sum of the products. And then you sum the weights, that gives you 12. That's the sum of the weight. So your weighted average, or the GPA in this case, will be 41 divided by 12. That is 3.42 semester GPA. So that's how your semester GPA is calculated. And I hope everyone here knows how to do that calculation now. Now, when you are working with frequency distribution, all right, sometimes the question would ask
Can
you
you go back
find,
up for a second?
okay. All right, so whilst I'm here, I'm also saying that if you're working with frequency distribution, your frequencies, the frequency serves as the weight. All right, so frequency is the same as weight, or frequency serves as your weight. Just like credit, your credit for a class serves as a weight. All right, so frequencies are also the weight when you have frequency distribution. All right, so I can give you something like this. I can do something like this. X, it's 4, 3, 4342. Then I can put F here, and I would say it is 5322. Then I would say find the mean. I can say find the mean. So if I do something like this, what you're gonna do is find the product first. 5 times that is 20. 3 times that is 9. This times this is 8. This time that is 4. Add it up, that gives you 41. Add your frequencies, that gives you 12. Then your mean will be 41 over 12. Same concept. So frequencies serves as weight. Frequency serves as weight. Credit also serves as weight when you are calculating semester GPAs. Okay. Now, so I was looking at frequencies. So you would see that it is a weight, all right, the score multiplied by the weight. All right, frequency serves as a weight. Frequency serves as the weight. Now, divided by the sum of the weight, but the sum of all the frequency is n, right? We use n to denote the sum of frequencies. All right. Now, in a group frequency, your x value is a midpoint, and that's what we're going to be doing next. In the group frequency, your x values are the midpoint. Your x values are the midpoint. Okay. So let's see this question. Now, for most practical situation, you only going to give in the class and then you're going to be given the frequency. Usually they will not give you the midpoint. So you got to come out with your own midpoint, right? How do we do midpoint? We're going to say 7 plus 18 over 2. That will give you 12.5, right? Then you can look at this. This is jumping by what? 12. Is jumping by 12. So you could add 12 plus 12 will give you plus 12 gives you this, plus 12 gives you that, plus 12. So once you get the first one, you could generate the remainder of the values by the class width, because what? The class width in this case is 12. So it's jumping by 12. All right. Now, once you know this, then you're going to do just the same concept. So what do? We're going to create a column for the product. So we're going to do 12.5 times 6. Then you write the answer. Then 24.5 times 10. Then you write the answer. 36.5 times 13. Then you write the answer. 48.5 times 8. You write the answer. 60.5 times 5. Write it out. 72.5 times 6. Write it out. And then what? 84.5 times 2. Write it out. So all you're going to do is to take the sum of the product, which is in this case is the x times the f, divided by the sum of the frequency, which is your weight. All right, so you add all the frequencies and then you is your denominator. Let me see if that thing is worked out here for you. All right, so all the multiplications are here. These are all the multiplications. The sum of the product, so this is the product, that's the product of x times f. All right, the sum of the products gives you this. So the numerator is 2089. The denominator is the sum of the frequencies, which in this case is 50. And then when you work it out, you get 41.8. 41.8. So take note of how when you're given if you're given a group frequency, you don't have any single number here. So the midpoint, you're going to change this into the midpoint. The midpoint becomes your x value. All right, then you times this, you times each one of these. The value times the weight. Frequency serves as weight. So you divide by the sum of the weights in this case, which is 50. Okay. Now, so I'm not going to do this problem, but some of your homework problems will look like this. Let's say it says calculate the final grade. All right, so give you homework. This is what the student scored. It gives you the points. So you're going to change the point into decimal. So these are your weights. These are your weights. So this is 0.05, this is 0.35, this is 0.20, this is 0.15, this is 0.25. Then you're going to multiply the score by that. So the product, so that is 85 times 0.05. Then you write the answer. Then 80 times 0.35, you write the answer. Then 100, sorry, 100 times 0.20, you write the answer. Then 90 times 0.15, write the answer. Then 93 times 0.25, write the answer. So take the sum of the product and divide by the sum of the weight. So you're going to have sum of the product divided by the sum of the weights. That's how to find a weighted means. All right, here, because these are group frequencies, you're gonna first find the midpoint. So you need the midpoint. You need x. Here, x is a midpoint. Then when you get a midpoint, so you're gonna get a midpoint for each one of these. Then you multiply by this. Then you get the product. You get a product. You get all the individual products. Sum of the product divided by the sum of the frequencies. All right. Frequencies also serves as weights. All right. So sum of the product divided by the sum of the weight. The same thing will happen here. You need the midpoint. When you get a midpoint, multiply the midpoint by each one of it to get a product. Take the sum of the product and then divide by the sum of the weight. So these are some of the homework problems that you will be having. Okay, now a question like this, question 4 here, note that when you see a diagram, be able to judge whether the skewness of it, so it looks more like skewed to the left, right? The long tail is on the left. If the long tail is on the left, the mean will be drawn more towards the side of the long tail. This is the mode, the median will be in the middle. So here, the mean would have a lower number than the median, right? Mean, then this will be the median, and this will be the mode, right? So the mean will be smaller. The mean will be smaller than the median. Okay, what do we have here? Oh, now this is a very interesting question. It says determine the measure of central tendency that will best represent the graph. Now this is what I want to say. All right. I'll say use median for one skewed distributions. Whether it's skewed to the left or right, it doesn't matter. The median is preferred. All right. Now, number 2, if there are outliers. All right. If there are outliers, irrespective of skewness, use the median. Okay. Use the median if it's skewed or if there are outliers. If any one of these happens, the median is preferred. Now, the mean is preferred for symmetric distribution without outliers. All right, the mean is preferred for symmetric distributions without outliers. Symmetric distributions without outliers. All right, so here this is like qualitative, so the things we're doing is quantitative. So when we come here, this looks like bell shaped. All right, this is symmetrical, so we're going to use the mean for it. All right, these are the heights. Remember when we talk about the weight, it looks like the height of the volleyball players are more bell shaped. That's nice. Okay, now these are adults. So here this looks symmetrical too, right? It looks very symmetrical to me. All right, so we're going to use the mean here. But here, even though this looks symmetrical, because of the outlier, we're going to use the median. All right. If there are outliers in your data, the preferred measure of central tendency that will best represent the graph the um, is the median in this case because they are outliers. Okay, so let's look at this question. It says consider the mean and the mode. So mean and mode only. Consider mean, consider mode. And it says a negative distribution. So negative skewed mean that the long tail is on the left side. All right, so long on the left. Now the mode is where the peak is, right? There's a peak, and then so there's a mode. The mean will be drawn towards where you have the long tail. So this is the mean. All right. So in this case, the mean will be smaller than the mean will be smaller than the mode. Right? The mean will be smaller than the mode. Okay. Actually, okay, let me look at this first before we go on. Now, when you look at this question, this what does this? This looks symmetrical, right? This look symmetrical. This looks skewed to the right. These look symmetrical, and then this looks skewed to the left because the long tail is on the left, long on the left, long on the right. All right, so this says which one is positively skewed, so that would be B. Right, the long tail is on the right. Now it says what, if something is skewed to the right, if it's skewed to the right, then it's positive. Right, if skewed to the right, then it's positive. This. Now, when you look at this diagram, the next diagram, when you look at this diagram, it looks more like it's skewed long to the right. It looks more like that, right? So this should be skewed to the right. Okay, and so forth and so forth, all right? So um, this looks symmetrical, all right? So the shape, so it says, what is the shape of the distribution? The shape of the distribution is approximately symmetrical. Now here, this is the long tail. Long tail is on the right side, so that would be skewed to the right. Here, the long tail is on the left side, so that's skewed. The distribution is skewed to the left. The median, so here they wanted to calculate the median, right? And note that because this is skewed, median preferred measure. All right, preferred measure is median. Over here, median preferred, but over here mean preferred because it looks symmetrical. All right, so over here median preferred because it's skewed to the skewed.